so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So this is going to factor as x cubed minus 9, and then x cubed plus 9. And at first glance, you may think that those are both sums and differences of cubes, but you don't know what the cube root of 9 is, and so you're actually just going to leave it as x cubed minus 9 times x cubed plus 9. Now looking at the next one, the math knowledge question, it says if x is less than or equal to 2, then x minus 2, the absolute value of that, equals what? If this is less than 2, that means that x minus 2 is going to be a negative number, and so if you wanted to get rid of the absolute values, you would take the negative of x minus 2. And so if you distribute that, you would just have negative x plus 2. Now you can check that with some values. Plug in x equals, let's plug in x equals 1. If we plug in x equals 1 here, we would have 1 minus 2, which is negative 1. Absolute value of that is a 1. If you plug it into this function, negative 1 plus 2 is also 1. Let's check for x equals negative 4. Plug it into this function right here. Negative 4 minus 2 is a negative 6. Absolute value of that gives you a 6. Plug it in over here, and you would have negative 4, so positive 4 plus 2. That also gives you a 6. So this is what that absolute value equals, and so your answer is going to be E for your math knowledge question. All right, so now we're going to look at lesson 90 today, dealing with particle motion part 2. We talked about particle motion part 1 a couple weeks ago. These are dealing with acceleration, velocity, position functions, but again, they're not actual particles that are on the Earth's surface. They give you random position, velocity, and acceleration functions. So the acceleration on these is not going to be 9.81 or negative 9.81 or 9.8 or negative 9.8. It's just going to be some random formula. So hopefully you'll understand particle motion part 2 after this lesson. So the definite integral of the velocity function of a particle that is moving along the x-axis is represented by the algebraic sum of the left, which is the negative distances, and the right, which is the positive distances that's traveled by the particle. If you integrate your velocity function, you're going to get to your position function. And so the definite integral of the velocity, that gives you your position function, that is going to tell you the distance that your particle actually traveled from one point to another. So we have the velocity function moving along the x-axis for our particle, given by v of t, and then they also tell us that when we integrate from 1 to 2 of our velocity function, we have a negative 7. What that means, when our particle moved from t equals 1 to t equals 2, we changed the distance of negative 7, so we went to the left 7. And then when we went from t equals 2 to t equals 3, we went a positive direction of 3. And then from time equals 3 to 4, we went backwards 2. And then from a time of 4 to 5, we actually went to the right 6. So that's what those are basically saying. You integrated your velocity function to get your position, and the position change is negative 7, 3, negative 2, and 6. So it asks, how much does the position of the particle change over the interval from 1 to 5? So we're starting at 1 and then going to 5. Well, in the first second, it went backwards by 7. And then we went forwards by 3, and then we went backwards by 2, and then we went forwards by 6. So if you add all of those up, you end up with a 0 net change. So our particle just went back and forth, and it ended exactly where it started from time 1 to time 5. Okay, so that's for part A. For part B, if the particle is at x equals 7 when time is 2, what is the position when time is 4? Well, when we go from time 2 to time 4, we went forward 3 and then backwards 2. So that's a total change of a 1. And if we started at a 7 and you add a 1 to it, you end at a change of an 8. So that's your actual position for your particle. Looking at the next example. A particle moves along the x-axis and they give us the position function. We want to know what are the positions of the particle at t equals 0 and t equals 3. So to find that, you're just going to do x of 0, and if you plug in 0, your position is going to be a 1. So that's the first one. And then you do time of 3. So if you plug in a 3 for your position, your position is going to actually give you a 10 at time of 3. And so the position at time 0 is 1, the position at time 3 is a 10. And then it wants to know what is the total distance the particle travels in between time 0 and time 3. So what we need to do is to figure out when it started changing directions. And so if you're going to do that, you're going to be looking for where the velocity equals 0. So in order to find the velocity, we're going to have to find the derivative of our position function, which is going to be 6t squared minus 18t plus 12. And so now we can factor out a 6. We'll have t squared minus 3t plus 2. And we can set this equal to 0 to figure out where our t changes directions. And we'll have a t equals 1 and 2. And so that means at time 1 and time 2, it changed directions. So it was going positively, and then it started going negatively, or it was going to the left, and then it started going to the right at time 1 and time 2. And so now to find the total distance the particle travels between time 0 and time 3, we are going to have to split it into 3 separate parts. We're going to go from time 0 to time 1. We're going to go from time 1 to time 2. And then we're going to also go from time 2 to time 3. And so we need to figure out what each of those integrals equals. Well, this first one, we need to figure out what our position at time 1 is. So we're going to have 2, 1 cubed minus 9, 1 squared, plus 12 times 1 plus 1. That's going to give you a 6. And then if you do the same thing for time 2, your position is going to be a 5. And so at time 0, we started at a 1. That's given here. And then at time 1, we got to a 6. So that's a change of 5. At time 1, we were at 6. And then at time 2, we got to 5. So we went backwards by 1. And then we started at 5 for time 2. And at time 3, we went to 10. So that's a change of 5. Now, it didn't ask about the position. It asked what is the total distance that the particle traveled. Well, in the first second, it traveled 5 units. We don't know what the units is. It traveled 5. In the next second, it went backwards 1. However, if you go backwards, you are still traveling a distance of 1. So we're going to add 1. Try and put your car in reverse and drive backwards and watch your odometer. Well, pay attention to where you're driving so you don't hit anything. But if you watch your odometer, it'll still continue to go up. So you have to add that distance as a positive number, not a negative number. And then the last second, we went another 5 units. So the total distance that we traveled would be 11. So during time from 0 to 3, it went 11 units total. Okay, looking at the next example, we have the acceleration of a particle moving on the x-axis is given as 4 pi cosine of t, and then they tell us the velocity is 1 at time 0, and we want to find the average velocity. Well, they tell us that our acceleration is 4 pi cosine of t. To find the velocity, we can actually integrate our acceleration, and you're going to get 4 pi sine of t and then plus c. And we need to figure out what our c is. The way that you're going to do that, our velocity is 1 when our t is 0. So 4 pi times sine of 0 is 0. So this whole term goes to 0, and so your c equals 1. So that means that your velocity function is going to be 4 pi sine of t plus 1. And then it asks for the average velocity of the particle over the interval from 0 to pi. Well, that's going to be used in the formula that we learned last lesson. So for our average velocity, we're going to have 1 over pi minus 0, and then integrating from 0 to pi, and we're going to integrate our velocity function. So 4 pi sine t plus 1 dt. If you integrate 4 sine t, you're going to have negative 4 pi cosine of t, and then if you integrate 1, you're going to have a t. And we're going from pi to 0. So we have 1 over pi, negative 4 pi cosine of pi plus pi, and then minus negative 4 pi cosine of 0 plus 0. Cosine of pi is just a negative 1. So I have negative 4 pi times negative 1 plus pi. And then I have minus negative 4 pi. Cosine of 0 is 1. And then I don't need to write that plus 0. So now I can have this as 1 over pi, 4 pi plus pi, and then plus 4 pi. And that will give you 1 over pi times 9 pi, which the pi's will cancel, and you'll just be left with 9. And its average velocity, velocity is just unit per second. And so that would be the average velocity for that function over the interval. So it's kind of combining what we did yesterday in the last lesson with the average velocity function, and then also dealing with the new part of the particle motion for the first half. Okay, looking at another example. The velocity function for a particle moving along the x-axis is given by this function here. And it wants to know, where is the particle stationary? Well, the particle is going to be stationary where your velocity equals 0. So I'm going to set my velocity function equal to 0. So I can divide by 2 pi, and I'm just going to have 0 equals cosine of pi t. Now, cosine of pi t is going to equal 0 when pi t equals either at pi over 2 or when pi t equals at 3 pi over 2. But it is going to keep repeating, and you basically would just add pi to each of those because it's a periodic function, and so it would also repeat at 5 pi over 2, and it would repeat at 7 pi over 2, etc. You could just go on and on and on forever and ever. And so if we solve for our t, divide by pi, and you get 1 over 2, t equals 3 over 2, t equals 5 over 2, t equals 7 over 2, etc. But it says on the interval from 0 to 2. The only ones of those that are on that interval are at 1/2 and 3/2. And so those are going to be the values where your velocity equals 0, which means that the particle is stationary. So those are your answers for that question. Now the next question relates to this one. It wants to know what's the total distance traveled to the left by the particle in the previous example between time 0 and time 2. So it is going to look, if I graph it, something like this, because it's a cosine curve. I could keep going that way if I wanted. And this is going to be the 1/2, and this is going to be the 3/2. And so it's moving to the left, right here, because that is when it is below the x-axis, when it's positive. So that's the part that I'm looking for the distance. So I'm going to integrate from 1/2 to 3/2 of the function that they had on the last example, which is 2 pi cosine of pi t dt. So if you integrate that, cosine is going to integrate as sine of pi t. And now I'm not sure what goes in front, so let's take the derivative of sine. The derivative of sine is cosine of pi t. And then the derivative of pi t is just pi. And so I need to put a 2 in front because I already have this pi here. I don't have a 2 though. And so that's how it integrates. And then we're going to plug in 3/2 and 1/2. So 2 sine of pi times 3/2 minus 2 sine of pi times 1/2. So we're basically looking at the sine of 3 pi/2 minus 2 sine of pi/2. So the sine of 3 pi/2 is -1. And then the sine of pi/2 is a 1. So I have -2 minus 2, which is -4. So looking back at the question, it says, what is the total distance traveled? Well, I got a -4. It's a negative because it was going backwards, because it's down here. But when you're talking about distance, you always want to have a positive number. So the total distance that it actually traveled is a 4 units. And it is negative because that means it was traveling to the left. But our actual distance is 4. Okay, so if you go back home after school this afternoon, you're not going to tell someone you went -20 miles home or -2 miles home. You went 10 or 20 or however far it was. But you're not going to say a negative for a distance. So that's why you don't want to use the negative for your answer there. So hopefully that helps you a little bit with the particle motion. You do get to omit number 16, 18, and 23 on your homework. So make sure that you do that tonight so that we can go over your questions tomorrow.